I want to help CIOs move beyond Chief Infrastructure Officer back to Chief Information Officer. Get them back in the driver's seat on helping organizations really deliver mission capabilities to their constituents. Welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. This is Darren Pulsford, Chief Solution Architect, author, and most importantly, your host. On today's episode, Enterprise Architecture for Government, with your host, me, Darren Pulsford. Hey, today I decided to do a monologue, and I wanted to talk a little bit about something I'm seeing starting to emerge in government and also in enterprise, and that is a real look at solution or holistic enterprise architecture. And it's something we've been working on for some time at Intel, and something that's a big passion for me. I'm starting to see organizations really buckle down hard on looking at their systems overall. In order to take an overall systems approach, just like we say with this podcast, it's all about people, process, policy, and technology. So in order to do a holistic look at enterprise architecture, we're going to have to look at those four different elements, specifically people, process, and technology, and see how they interact with each other and come up with an architecture that shows that interaction and shows how they work in coordination together to provide real value to the organization. So if I take those four key elements and I start mapping those elements to architecture, we get something that we call GEAR, the Government Enterprise Architecture Reference. And it has four critical elements: a process architecture, an organizational architecture, a physical architecture, and a logical architecture. And in today's episode, we're going to go over each one of those at a pretty high level so you can see how they interact with each other and the importance each play in really developing solutions that last a long time, that don't put you into into a technical debt, and how you can leverage silicon across this whole spectrum. That's the goal that we want to get to. So let's dive first into organizational architecture. Now, organizational architecture is very specific to people. This is how people are organized in your organization, in your department, but it's not just how they're structured, but it's also all the different aspects to it. And we first start at the top of the organizational architecture with stakeholders. Who are the critical stakeholders in your department? Now, it's important to understand with government, you have a unique set of stakeholders that is different than most commercial organizations. Most commercial organizations, especially if they're public, they have shareholders, they've got customers, they've got partners, and they have employees, right? A little bit different for government in that you have constituents. Your shareholders, I guess they could be your constituents, but they're also your customers, your citizens, or your constituents. They provide you the money, and they also get services from you. So these stakeholders are a little bit different than your typical customer or shareholder. It's kind of a combination of both. You still have employees that are shareholders. You've got your executive management that are stakeholders. So it's important to understand what each stakeholder brings to the table, what motivates them, what their role is really in your department, in your organization. So identifying the stakeholders, critical, first thing. Now, if I go down to the next level, now we're going to talk about personas. Now, what's the difference between a stakeholder and a persona? A persona is an archetype of, and a persona can be just a generalization of the type of stakeholders that I have. So it could be a management persona. It could be a certain type of constituent as your persona. It could be someone that needs more services than others. A persona of a constituent could be a taxpayer. It could be a welfare recipient. Persona could be a commander of a division. It could be a CIO, a middle manager. There's lots of different personas out there. We're cataloging all these personas so that we can understand better what motivates each individual persona. So if you take a look, stakeholders map to personas, right? Where I can get down into a little bit more details into their motivations and the differences between the different types of stakeholders that I've identified above. Then I take those personas and I break those down into roles and responsibilities. Now, this is where you start getting into things that we normally see in organizations. Your role is this, your responsibilities are that. I have personas that map to roles and responsibilities. I have roles and responsibilities that can cover multiple personas or vice versa. The persona is more of a logical construct where the roles and responsibilities are like brass tacks. I'm getting down to what is this person or this person in this role supposed to be, right? I can have multiple personas for the same role. I can have a innovative manager and I can have a operational manager. Their roles may be the same, but their personas could be different. Their responsibilities may be different a little bit too, but it's good to understand what those different characteristics are of the different personas. Then, side by side, underneath personas and side by side with roles and responsibilities, I've got skills and competencies. I've seen a lot of organizations doing skill mapping right now. They need to understand what skills do we have currently, where are our gaps, where do we need to do training and things like that. Skills and competencies are a very important aspect that we need to make sure that we're capturing. Especially now as we're seeing a major paradigm shift, bring back an old word from the 90s, a big, huge paradigm shift into generative AI and AI technologies. As we're seeing roles and responsibilities change, that means skills and competencies are going to have to change. We're going to have to train people up and things like that. Next to skills and competencies and roles and responsibilities is structure. Now, there are tons of books out there, organizational management books, on how to structure your organization. Do we go vertical? Do we do horizontal? Do we do hierarchical? Do we do matrix? There are so many different options here, so many different things to look at, but that is all directed by core foundational aspect here, which is the culture and values of the organization. Recently, I was talking to a couple of my customers in Department of Defense, and they say, well, we don't really dictate our own culture and value. It's the government that does. And I reminded them that their department in the Department of Defense is very different than a sister department who has different traditions and culture and values than they do. And those little idiosyncrasies between the different organizations cause a major effect in the way that they structure themselves, the way that they have roles and responsibilities, and the last element here, which is communication channels. So communication channels are guided by culture and values, whether it's a open door communication policy and I have a very flat structure, not very hierarchical. Communication channels are very wide, but can be confusing. Or if I have highly hierarchical, communication channels are very well defined, and chain of command is very important in those. So understanding the different communication channels based off of the culture and values, the structure of the organization, and how the stakeholders all play together. All of these elements, all 7 of these elements, have an important role, and we need to understand those and how they fit together. Okay, next, let's talk about process. Now, I've got my organization. They can't do anything without some kind of process. So when we started looking at process and we started looking at how in the world do I capture all the processes across an organization or a government agency, that's just so complicated. So we started looking at different ways to describe processes and group them into buckets together so that we could better understand and start helping organizations unravel years and years of ad hoc processes that have been created because of policy or because of previous administrations, whatever the case may be. And we found that we could boil this down into approximately 6 or 7 different major categories. When I look at it, there's 7, right? And the 7 are mission and vision processes, strategy processes, governance processes, innovation and new capability processes, operational processes, risk management processes, and kind of a catch-all, which we call support processes. So let's start first with support processes. Support processes support the rest of the organization in getting their mission and vision passed into operational capabilities and services for their constituents. So the support process on the bottom is foundational to helping the organization achieve their mission. That's the key aspect of it. So in this, you're going to see HR, financial, IT support, those sorts of things, facilities processes, those sorts of things you're going to see in the support processes. Right? The rest of the processes rely on a solid foundation of support processes that can help achieve the goals of the organization. So let's start with mission and vision. So if I look at mission and vision processes, they are the beginning of kind of this whole process concept. So if I can establish my vision and my mission and the capabilities that I want to deliver and the process for capturing those feed into my strategy processes, which in addition to governance processes and risk management processes, help me build a solid strategy. So the governance processes and the risk management processes feed into the strategy processes to really get me my strategic long-term plan, my short-term plan, whatever the case may be, my strategy. Then what is delivered out of the strategy processes goes into innovation and new capability processes, where I'm developing new capabilities, I'm developing new services, whatever the case may be. These are your traditional development processes, either product or software development or service development processes. This is your ideation, R&D, all that fits into the innovation and capability processes. And then once I'm developed and I'm getting ready to deliver, it moves over into operational. Now, operational are, I've got the process, it's ready to be sent out to constituents. It is operational. It's turn the crank, make sure it's working. This is your disaster recovery, business continuity, deployment, operational, your service level agreements, your quality of service processes, those all fit into that operational. Additionally, if you're running critical infrastructure, power plants, water plants, hospital, healthcare, chemical manufacturing of goods and services, operational processes fit in there. This is where I'm really delivering the services and capabilities that I've developed in my innovation and capabilities processes. There are hundreds of processes that we've identified that fit into these 7 buckets. Going through all of them is going to be really, really difficult. But what we've decided to do here is we have generalized these into what we call level 2 processes. So now I can start taking a look at what areas of my organization I might have gaps. And we have best known methods, best practices, processes that are well known out there that you can take advantage of. And the key to understanding the processes is understanding how they map onto the logical infrastructure that in order to automate or to support these processes that we've talked about. So you can see I've got Organizational architecture. That process architecture drives and helps the organization function appropriately. There's these great feedback loops into, hey, this process that we have doesn't quite fit our organization. We can make a decision. Do we change the organization structure to help manage a better process and optimize my process, or do we change the process? And those are great decisions that the C-suite needs to understand and make those decisions. All right, let's dive into the next layer, because we could talk on each one of these for a good solid hour, but we don't have an hour for each one. We've only got like 5 or 10 minutes. So let's move on to the next layer. This layer is what we call the logical architecture. Now, this layer here is your software stack, your traditional software stack that you all have. Everyone has applications today. Typically, your IT organization is managing this. They're managing the infrastructure of this. And this is really broken down into 6, 7 layers itself as well. Wow, 6 and 7, those are magical numbers, I guess. All right, so if I take a look at this, the foundation of logical architecture is what I call the physical layer. Now, there is a physical architecture too, which we'll get to. This physical layer of the logical architecture is a representation of your physical devices, right? It is a abstraction of that physical. So I need this layer in here. And inside the physical layer, we have something called a minimal viable device. This says that this device can be managed. I can look at it, I can get telemetry off it, and I can shut it off, I can turn it on, I can power cycle it, I can do firmware upgrades, I can do BIOS upgrades, whatever I need to. There's a minimal set of functionality that's required for a minimal device. And that's important to understand. Also, the physical layer helps me catalog and categorize my physical devices that I have out there. So I'm not going to talk any more about that, because when we talk about the physical architecture, you're going to find out a lot more about the physical layer. On top of the physical layer, we have the software-defined infrastructure. Now, this has been around for some time, and in industry, when people typically talk software-defined infrastructure, they think fully virtualized. Well, that's not the case. A software-defined infrastructure needs to span edge devices. They need to be in the cloud, in the data center, on your desktop, your phone. The idea of a software-defined infrastructure is that I can provision infrastructure to do specific things, whether it's run applications, I need to update it, or whatever. The software-defined infrastructure has all the tools and layers inside it to do software-defined compute, storage, network, security, accelerators, whatever the case may be. This, a lot of times, is implemented through virtualization, but is not necessarily implemented always through virtualization. There are lots of opportunities out there and lots of tools out there that can do bare metal provisioning of infrastructure for you, right? And in many cases, especially on your OT side, your operational technology side, a lot of this software-defined infrastructure doesn't exist in many people's organizations, but there are software stacks that let you do it. It's important to identify if you're not using it, you're probably doing it by hand, which is highly inefficient. So this is another thing where we can take a look at process. Can I replace a process with something that's more automated and reduce time to value, reduce cyber threat attacks? There's a whole bunch of things that it reduces by putting that automation layer in. Okay, on top of the software-defined infrastructure layer, which handles multi-cloud, virtualization, bare metal provisioning, all the things, right? On top of that, there are 2 layers that have this beautiful dance between each other. They work with each other to get data and services and applications all put in the right place at the right time. One of them is the service management layer, and the other one is what we're calling the distributed information management layer. Let's first talk about service management layer. The service management layer is all about deploying and managing services and applications, individual services and applications. This includes a lot of people say, oh, that's microservices. Well, it is microservices in addition to application deployment and orchestration. So this is when I'm actually like Kubernetes, Tanzu, Red Hat OpenShift. These are some products in this space in the service management layer. The idea here is that they're managing services. They talk down to the software-defined infrastructure layer and say, I need this many machines because I'm going to run these services on it. So it's making the requests of the software-defined infrastructure layer. It's provisioning things, and then it's dropping the services on there. In conjunction with the service management layer, I said there's this beautiful dance between the service management layer and the distributed information management layer. The distributed information management layer is a new one. This is new because people traditionally said, well, I'm just going to put all my data into one big bucket, whether it's in the cloud or in the data center. Because of the proliferation of IoT and smart devices, we're now seeing that I can't move all the data into one place. So now I need to actually orchestrate data and services in this kabuki dance, right? Where they're deciding, do I move the data? Do I move a service? Many times it's easier to move a service close to the data and run analytics than to move the whole data set somewhere. So this orchestration between service management layer and distributed information management layer is a new area of research that a lot of people are dabbling in, and we're starting to see the emergence of some new tools in the distributed information management layer space. Really cool stuff is happening in there. And most people in their current enterprise are not doing this very well yet. So watch for that one. On top of all of this is what we have, the application layer. And in this, I've abstracted up a little bit higher than services in that an application is made up of several services, and there's a workflow engine in here. There's DevSecOps pipelining in here, AI/ML devices or AI/ML algorithms, frameworks, all the things that you need to develop full-blown applications fit in that application layer. So the layers underneath it are foundational to provide the services that the application layer and software developers, AI developers, data scientists can really get their work done highly effectively. In conjunction with these layers I've talked about, there are two aspects. One is called the identity aspect, and the other one is called the security aspect. The identity aspect is all about identifying elements in the architecture, whether they're individual people, whether they're applications, data, physical devices, logical, virtual devices, services, whatever I need to uniquely identify those and do my normal traditional AAA security, access, authorization, authentication. I need to have those on all of the elements in the architecture. That is critical. Also in the identity aspect, we're going to handle all of our security keys and all the aspects that go around uniquely identifying and encrypting and decrypting technology. So key management all fits in there. The security aspect handles all of my other traditional security, and it handles it across the whole realm. So a lot of times security and identity are kind of meshed together. We've separated them out because we want more clarity around their different roles. But key foundational is that the rest of the architecture sits on top of a secure and identity-laden architecture. That's critical. On the security aspect, we have hardware root of trust, detection, remediation, quarantine, secure supply chain, all the traditional things that we have in the security aspect. I could go deep into each one of these. As I've mentioned before, we don't have time. Okay, the last element here that I want to talk about is what we call the physical architecture. Now, this one's really interesting because people are going to say, Darren, you can't map out everyone's physical architecture. Well, the goal of this enterprise architecture for government is not to have one architecture that rules them all, but to help organizations explain what they currently have. So the idea of each one of these elements is that I can categorize what I currently have in a way that groups them into groups that have characteristics that are common. And if I can do that, that helps me understand how to manage it, the processes involved in managing them, the software stacks that need to go on them, the organizational structure around them. This is foundational for us understanding our organization's physical devices. Now, this one's really simple. We had to make it simple because in the wild, this is so complex. So all we did was something simple. We said, hey, let's group my physical devices into 4 buckets. I've got cloud/data center. This is my fixed locations. They could be remote or on-prem. They could be in the cloud or in my data center. As you can see, this cloud and data center, these resources are pretty well known. I've got SLAs around them. There's different characteristics between data center resources and cloud resources, but in general, they all kind of behave somewhat the same. So we put them into one bucket. We argued whether we should separate them out, but we're starting to see a convergence of cloud and data center resources, so they're looking as if they are one, which is good. We kind of want to go that route. So that's one bucket. The next bucket is what we call enterprise IT bucket. This one is traditional laptops, desktops, even micro data centers fit into this realm. This is to keep my enterprise running, right? My day-to-day work. This is even your remote workers all fit in that enterprise IT side. Right? Okay, then the next bucket we have is called the operations edge. Now, those of you that are in operational technology, that you manage critical infrastructure, I know you already know this stuff, right? Operational edge, not a big deal. But this is handling robots, sensors, fixed cameras, smart city kind of things, right? Anything IoT. So in my house, for example, if I have a fridge that's an IoT device, that's my operational edge. Got it? All right, operational edge. Or if I have in my factory a plasma cutter, operational edge. Or I've got cameras all over my house. I got a Ring camera and lots of other cameras, operational edge, operations edge, right there. That's the bucket it fits in. Now there's another bucket, and it's on the edge as well. Now, at first we grouped these together. We call it the dynamic edge. But we separated them. Why? Because the dynamic edge has some very unique characteristics that are fundamentally different than the operations edge. And that the primary thing that we see on the dynamic edge is the mobility of the device and the intermittent comms, something that the military knows as DDIL, for denied, disrupted, intermittent, and limited bandwidth or limited, functionality. That's the dynamic edge. So what fits in there? It could be mobile phones. It could be tablets out in the field. It could be drones, mobile fleet, anything in that realm, right? Where these things are moving around a lot. They're not in a fixed location. They're mobile sensors, things like that. That's your dynamic edge. The characteristics on that are very different than the ones in my operational edge, where it's a more fixed location. I probably have hardwired internet connectivity, or I have Wi-Fi 6 or 7 or 5G, whatever the case may be, but it's more fixed. That's the main difference. Understanding your assets and how they fit into these buckets is critical, because once I've done that, I map that to the physical layer in the logical architecture, which now I can start saying, how do I manage these resources across this whole ecosystem? How can I deploy new services and applications? Do I have a software-defined infrastructure layer there? Or am I doing it by hand? This is where we start looking at the processes and the interaction of the processes with the logical architecture and finding those gaps. Because if I can find those gaps and I can automate them, I can increase reliability, functionality, security, and I can really make your organization hum. So hopefully you can see all four of these key elements that I've talked about, the organizational architecture, the process architecture, the physical architecture, and the logical architecture, you can see how they all interact together to help organizations deliver mission and capabilities to their constituents. Because ultimately, that is the role of your organization. You've got a mission and you want to deliver it. So let's make sure that we're focusing our efforts and our architecture on delivering that mission. I've mentioned several times in my podcast and in meetings that I want to help CIOs move beyond Chief Infrastructure Officer back to Chief Information Officer. Get them back in the driver's seat on helping organizations really deliver mission capabilities to their constituents. Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and embrace the digital revolution.